So, hello everyone, and welcome all of you to this weekly session, Ask AuxEn Anything, that we conduct. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their doubts or queries that they may have related to any project that they are doing or any RCC steel design concept or construction or site issues. So, this is the 63rd such episode that we are conducting. And let us begin by taking the questions for this week. So first, we will take the questions from the Google form, and then we will take the questions from live audience and email. So first, I'll take queries from Google form and email. Then I'll take the queries from the live audience. So let us begin. And the first question for this week's episode is from Engineer Akash Babar. He is a working professional from Sangli, and he's asking, uh, please explain one-way shear and two-way shear checks in raft with beams connected to columns. Please refer my question and diagram sent on email. Are you able to see this? I hope the screen is visible. Okay. So he has sent one. You're not audible. Am I audible to all of you? Is my voice audible? No. But my mic is not on mute. Okay. All right. All right. So, the first query Mr. Akash is asking, and he has sent one uh, image. So let me take that image. So he has shared it on the email. I'll just open it. So he's asking, so he is saying he has a 600 thick raft with strap beams. So this is his raft, and these are the beams that you can see. Reinforcement is this bottom mesh, and top mesh is this. On both left and right sides, the columns are flushed with property line over here, if you can see, on all the left and right edges. Total raft thickness is this, cover is this, effective this is, critical section is this. If there was no connecting beam in raft from C1 to C2, then we would have checked for one-way shear at D equal to 534 and determined the raft thickness for one-way shear. If there was no connecting beam at raft from C1 to C2, where is C1, where is C2? Okay, this. Then we would have checked for one-way shear. But in this case, a strap beam of size is provided in raft with this. So is there a need to check again one-way shear in raft after provision of beams? Since all the columns are tied with strap beams in foundation level, will punching shear come into action? See, one-way shear you have to check. One-way shear you will have to check whether you have provided a beam or you have not provided a beam. Okay. Now, if you have provided a beam, chances are that your stress level, stress contours, when you will see the stress contours for shear, they will be in this region. So now, let's say if you did not have a beam, then your one-way shear would have been concentrated around this region or this edge. Now, since you have a beam over here, the one-way shear will have a stress contour like this. and you can see that from the diagrams. So for the case where you do not have a beam, let's assume that this is axis 1, this is axis 2. So you will see V13 to be the V13 having a substantially large value. And just hold on, I'll be back. Yeah, so in that case, then your one way shear will be like this. So V13 stresses will be governing. If you have a beam, then you will observe that V23 stresses will be governing in the vicinity of your tie beam. Of course, it depends on the stiffness of tie beam and the size of the tie beam also. But this is just a general uh, principle that I'm giving you. Okay. So if you are checking, let's say you do not have a beam, you check at d distance from the face of this column support. If you have provided a beam, check at d distance from the face of beam. Again, for punching, it depends. I mean, safe software will not check punching if you have tied it with beams, but then a good way to check whether punching stresses are getting critical even after providing the beams is to check for the S max stresses. So you have the option of, let's say, generally we see for the forces and moments, but then you have the option of viewing the resultant stresses also, resultant shell stresses. So you check for S1 3 and S2 3, and then there is an option for S max. So when you turn on this S max option, you get a good sense of how the maximum shear stresses are distributed. So if you are getting a closed surface of this S max stresses, it will indicate, or it's an indication that punching is critical or punching needs to be looked into. If you are not getting a closed surface, let's say for these S max stresses, then you can sort of conclude that punching may not be uh, important. Okay, so I hope this answers your question. Next question is from engineer Dhruv Jyoti Ghosh, and he's asking, please let me know. So Mr. Dhruv Jyoti Ghosh is an independent consultant from Siliguri. What he's asking is, please let me know when P delta would be mandatory for design. See, P delta is basically to account for the geometric non-linearity of your vertical members. Okay, so your vertical members like columns, uh, they under the effect of lateral load have a tendency to sway, and due to those under those sway conditions, because of the axial load acting, there might be some moments, additional moments that may be generated due to the geometric non-linearity. I am not using the word material non-linearity, I am saying geometric non-linearity. Similarly, a column, when it buckles under the effects of axial load, then also there is another p small delta moments that we have to consider. So basically the p delta and p small delta effects are to consider the geometric nonlinearity of your vertical members. So different design codes deal with this situation differently. In your normal design processes, we use some additional moments, like in IS 456. If I was to tell you, you have the option of magnifying the moments to factor in the sway effects and to factor in this p small delta. So I think the clause number 39 point something, it gives you this additional moments to be considered, right? If you so that is called as generally the first order analysis. If you want to do a geometric or a second order analysis, then you have to do it on the uh, generally you have to do it on the software, because software are capable of doing those analysis, carrying out those analysis procedures. So with tall structures, what happens is that, and with the improvement in software these days, it has become very easy to run a p delta analysis. Just at a click of the button, you can just your software like STAD and ETABS will run it for you. So these days the codes also then tell you that instead of using the first order analysis, where we consider the geometric nonlinearity by some moment magnification factors, instead of that, your codes, design codes these days tell you that run a p delta analysis. So more critical your structure, your code will govern, or code will tell you to run a p delta analysis as mandatory if the structure is critical, or if there is large amounts of lateral sway which is given by your stability index. So if stability index, q, some codes call it as q, some other codes call it with some different name. So if your columns are slender, or if the columns have large sway, then your code, or if your columns are part of, let's say, a tall structure or whatever, then your codes will make it mandatory for you to use the p delta effects. Otherwise, you can continue with the uh, first order analysis and consider moment magnification using some codal formulae. Okay. Then his next query is Mr. Dhruv Jyoti Ghosh is asking, in hot and humid climate of metropolitan cities like Kolkata, which range of floor levels is ideal to reduce humidity? I don't know, frankly. Uh, I don't have I don't have answer to this query. Maybe somewhere near middle, because if you're at the upper floors, maybe the you might get a lot of heat from the roof levels. If you are very near to the ground floor, maybe the airflow is obstructed due to adjacent structures. So maybe somewhere near middle, but I'm not sure. Is there any construction method for very low height buildings to tackle humidity? I think maintaining proper ventilation, having proper ventilation and fenestrations or shades, louvers. They can be either fixed louvers made in RCC, or uh, louvers these days in aluminum cladding or whatever. But maybe ensuring proper ventilation, proper shades, and proper provision of louvers may help you to tackle humidity. Although uh, I don't have much knowledge about it. Should buyer prefer low rise house over high rise flat? Again, I have no opinion on this. It depends on the budget of the buyer. It depends on the locality. It depends on a lot of things. So I don't think this is a straightforward uh, choice that the buyer may always have. It depends on a lot of factors. So yeah, I don't have good answers to any of this question. Uh, Next question is from Engineer Shashank Kumar. He is joining us from Nalanda. He is an independent consultant as well as a faculty member. So he is asking, uh, oh, okay. So this is interesting question he's asking. Few days ago, I met a PEB supplier. He said PEB structures are designed based on MBMA standards instead of Indian standards, stating that this results in reduced steel tonnage. I would like to know, is it appropriate or permissible to design PEB structures in India solely based on MBMA guidelines without complying with IS codes? Does designing based on MBMA AISC actually reduce tonnage? From a professional and code compliance perspective, what is the correct and safe approach. So anyone in the audience has any thoughts on this, on MBMA standards? So yes, anyone has any thoughts? No thoughts? Volume. Is my voice not audible? I think it is audible. Yeah, MBMA. Should we use? Are we allowed to use? What is MBMA? If you are doing pre-engineered buildings, what to do? So MBMA, you must understand first of all, it's not a design code in itself. It is just a guideline. Okay, it is not a design code. It's a guideline. What is the full form of MBMA? MBMA is Metal Building Manufacturers Association. So it is just an association of metal building manufacturers. So let's say the PB industry suppliers have come together and formed this sort of an association. Now, the design codes that they refer to are your AISC and ASCE standards. So MBMA is not a code in itself. It will refer you to AISC for design and ASCE for loading. Now the problem is, okay, I think the volume issue is now sorted. Now the problem with this is very important that your ASCE codes give the wind and EQ loads for at ultimate levels. So the wind speeds, design wind speeds, and the EQ spectral acceleration factors like SS, S1 are given at your ultimate levels. Just understand what I'm trying to say. Now, because they are given at ultimate levels, or let's say they are given for a higher return period. So if you understand the probability concept, if any loading is given for a higher return period, its magnitude will be higher or lower. Suppose I have a load 1 which is given for, let's say, 100-year return period, and if I have a load 2 which is given for a 400-year return period, if you understand the probability concepts, which will have a higher magnitude, load 1 or load 2? Tell me. No answer. These are my return periods. These are my loads, let's say. So if a load is given for a return period of 100 years, and if a load 2 is given for a return period of 400 years, magnitude wise, which will have a higher magnitude? So naturally, the one which has a higher return period, that means it is less probabilistic to occur. So if it is less probabilistic to occur, it has a more intensity, because frequent events that occur are not, I should say, frequent events are not, or regular events or events which happen with regularity, especially in cases of wind and seismic. So events which happen with regularity have a lesser magnitude as compared to an event which has a very low probability to occur or a very, very high return period. It will have a higher magnitude. Is this point clear, first of all? Okay. So load 2 will have a greater magnitude as compared to load 1. Now the problem is that ASCE gives you loading at, since the ASCE 10 version, right now the ASCE that was revised is the 22 version, 2022. So since the ASCE 7 2010 version, they have sort of made the return periods to be at the higher levels. So now the wind and seismic return periods have been readjusted to a higher level magnitudes. So since the return periods have been adjusted to a higher value, what has happened is that the magnitudes of wind and seismic that you now get from ASE 722, let's say, are greater than what you would get for the ASE 7, which was before 2010. So because of this, what they have done is that they have adjusted the load combinations by reducing the factors for wind and EQ. Do you understand? So now the wind and EQ are, let's say, with a factor 1. Why? Because the magnitude has been increased. So to keep the overall load combination value similar, now they have reduced the combination factors. In a before the ASC 710, they had higher magnitudes like this. Okay, the load combination factors were higher. Are you with me so far? So the readjustment made has been that because now the wind and seismic are given for larger return periods, so they are of larger magnitudes. So to sort of make them comparable, what has been done is that their load combination factor has been made as 1. You understand? So this is the change. This is the change that has been done. Now the problem occurs when you use the IS codes. So now what is happening is what the Indian PV industry people are doing, that they want to use the MBMA. Okay, because somehow they think that MBMA or AISC, ASC standards are to be used. The problem happens when they take the wind and seismic from IS codes. So they will use IS 875 part 3, or they will use IS 1893. So they will take the wind and seismic from this. Now the wind and seismic magnitudes for these codes are still for lower return periods. Okay, are still for lower return periods. And that is why in Indian code we still have the combination like this. So we will have a 1.5 plus 1.5 like this, or we may have 1.5 dead plus 1.5 wind like this. Why? Because our return periods were for a lower return period. So problem is that the MBMA, what jugglery these people are doing, that they take the codes from this, sorry, they'll take the loads from this, which are for a return period which is lower, and then what they do, they use the load combinations like this. So that is a big mistake. Do you understand? Hello? They will use the load combinations from the AISC or ASC standard. So this is a big mistake. Why? Because you are using lesser values of wind and seismic. So if you want equivalence, then you should have used the load combinations also that were given to you before ASC 710. So if you are using newer ASC which has load combinations like this, then please remember that these are for earthquake and wind loads for a larger return period. So you cannot use the loads from these codes 1893 and 875 part 3 because they are still for a lower return period. So this is the problem that people are making, or this is the mistake that people are committing. And naturally, if you are designing for reduced load combinations, naturally you will get reduced tonnage, but it is unsafe, incorrect, and improper. So if at all you want to use the AISC standard and ASC standard, what I will suggest is that you take the loads from 875 part 3, you take the loads from IS 1893 to part 1, you make the load combinations also as per the Indian code, and then if you want, you run the design using the AISC 360. That you can do. Then it will not be a problem. So if you want to do it appropriately, this is what you should do. So this was my answer that I wanted to give. So does designing based on MBMA AISC actually reduce tonnage? I have already explained what is the mistake that people are committing. It should not be made. See, there is some saving that you get when you design it by AIC 360/22 as compared to IS 800 2007. Even if your load levels are same, still you get some 5 to 6% saving because the formulae given in AIC 360/22 allow you some higher, let's say, lateral torsional buckling strengths. So in compression, you won't find much difference. In flexure, yes, you do get some advantage because of some LTV effects that are under calculated in IS 800 2007, and some higher values are allowed in AISC 360/22. But it's only 5-6%, and in overall project, even that will not be there for the simple fact that your rafters and columns and general members have a very low lateral torsion buckling length and uh, compression flexural buckling lengths. So at very low lengths, the differences disappear basically. So almost similar tonnage you will get if you're using AISC or IS code. Okay. From a professional and a code compliance perspective, what is the correct and safe approach? I have already explained what you should do. If you want to use AISC 360 for design, you take the loads from 875 part 3, 1893 part 1, take the load combinations also as per the Indian code, and then if you want to use the AISC for design, you may do it. Okay, so this was the answer to his query. Then we have the next question from engineer Tawqir Ahmed. He is from Pakistan and he is a working professional. So he is asking, I have been assigned to design a single-story load-bearing community center located in seismic zone 4 using Koto panels. So I checked for Koto panels. They are basically uh, something like modular panels. Modular cellular panels. I'm just looking for an image. So this is the image I got from the internet. Something like this. Could you please guide me on how I should proceed with this with a timber roof truss system? So he has this modular walls with a timber roof. I would like to know whether it is necessary to model the structure in ETABS or SAP if required. I would appreciate if you explain how the modeling should be carried out. I have also emailed the Koto panel manuals. I did not get these manuals on the email I checked. So it looks like some cellular walls, prefab walls, and so he's trying to use this as his load bearing system. So maybe this is the plan view, and he wants to use this as his load bearing system. And on the top, there are only timber roof trusses that he's putting. So one thing you need to check is that whether this roof truss will it be able to transfer the lateral loads, or will it act as a diaphragm, and will it be effective in transferring the lateral loads? Let's say if my lateral loads are acting like this, will it be effective enough? Will that timber truss be effective to ensure that these two walls are tied together by the truss? That is the first thing that you should check. So for that, I think whatever is the axial load or whatever is the lateral load, your truss should be capable enough of taking it in compression. So that is the first thing you need to check. Let's assume that this timber truss is not going to be effective and it's not going to help you in transferring the lateral loads to the wall panels, vertical walls. Then I would say that you need to then consider the strength of these to help you to transfer the lateral loads to these walls. So just like your So for example, this is the direction of lateral load. This will be sort of your collector element, and this will help you to transfer the lateral loads to these cords. So I think your analysis you should do, and it is better that you make a complete shell-like model. It's better that whatever is your plan view for your load-bearing structure, you can make a shell model of that maybe, and then try to see that how the lateral load distribution is being taken by individual walls, and just check their stress levels, and then compare it with your wall manual, that uh, whether your wall panels will be able to take those loads or not. Okay, so I think that is how you can proceed over here. All right, then the next question is from engineer Vineet Kabadi. He is from Pune and he is a working professional. So he is asking how to implement the cantilever clause. So Indian code tells you that all the horizontal projections you have to design for 5 times the vertical earthquake. So he's asking how to implement that. So for first you will need to define your vertical earthquake. We had discussed uh, the definition of how to define vertical earthquake in ETABS in the last session that we had conducted last weekend. So you could refer that. Basically, you will have to make response spectrum. Manually, you will have to put time period values, and you put the AV value as 2/3 of AH. So those values you put first of all. Then you make load combinations. Let's say your load combination 1.5 dead plus 1.5, and you make a 5 times of vertical earthquake. Let's call it as EQZ. So you make these combinations. Because I think the clause says that you have to design for 5 times. Yeah. So you make this type of a combination. Then you use those combinations to analyze your horizontal projections. And then accordingly, uh, you provide the sizes and design it. Then his next query is how to design gravity columns in ETAS. This will be a long answer, so I don't know how to put it right now. But you have to maintain the deformation compatibility in your gravity columns. So first of all, whatever is your main model, you will have to ensure that the lateral loads or the effects of lateral loads don't flow to your columns. That is the first thing that you need to ensure. So for that, maybe you need to provide, I don't know how to do it. Actually, you will have to make multiple things. So I'm just thinking, when you have your columns, okay, if it is connected to beams, see, releasing the movements due to earthquake loads, that is simple. You just provide, let's say, if you provide a moment release to your column ends, then moments due to earthquake will not be transferred. The problem is that the axial load effects due to earthquake, that also should not be transferred to your columns. That is the tricky part. So if you provide very little axial stiffness to your columns, if you provide very little axial stiffness to columns, the problem is that the axial distribution to walls also change. That is the problem. So then you will have to make multiple models. You will have to make multiple models, and maybe you assign something like a pin support at the column points. Okay, you maybe assign a pin support at the column points, run your analysis, but then it changes the stiffness also. So I'll answer this question in the next week's episode. I'll think a better way to answer it. In one of our courses, we have covered the issue of gravity columns, where we had made multiple models and all those things. But then I will think about it and I'll present it in a better way next episode. So put this question in the Google form for next episode also. Okay, is this clear? Yeah, put this query in the Google form for next episode also. Mr. Vineet is asking, can we take R equal to 1 while designing gravity columns? No. So while designing the gravity columns, your code says that you have to take the deformation compatibility has to be maintained. So you need to make a separate model and you have to magnify your earthquake forces by R times. And over there, you need to design your columns for the moments that get generated due to those effects. So you ask this question next week, put it over there. I'll try to take it up once again. In one of our courses on flat slabs, we had dealt with this issue where we had made, I think, 3 or 4 models. But right now, I'm not able to recall it quite well. Okay. All right. So this was Engineer Vineet's query. Then we have the next question is from Engineer Praveen Vaishnav. He is a working professional from Mumbai. He is saying, if in a building considering R equal to 4, 100% participation is taken by wall, then for ordinary columns for design, should we have to consider only this or also consider EQ combinations? So he's saying nothing. No, but then remember that maybe shear is taken by walls. That I can agree that, yeah, most of the shear will be resisted by the walls. But what about axial forces generated due to lateral load? That you check. If axial forces are getting generated due to lateral loads, that means column is taking some amount of overturning moments, or column is resisting overturning moments. Okay. Yeah. So you check that, and then this question will lead back to the discussion on gravity columns. So I think I'll answer this question in the next week's episode. So check out the episode that we'll conduct next week, because I'll take the issue of gravity columns over there once again. All right. Then we have next question from Engineer Vasu. He's an independent consultant from Junagadh, and he's asking, he has the following query. Okay, wait a minute. He is asking, there is a doubt regarding the interaction of anchors provided reinforcement in the pedestal. Currently, Idea Statica is not supporting concrete details as per IS code. So we need to put certain values in shown formulae. Consider a case where all info about pedestal is with us. Its size is this. This is the depth and provided reinforcement. So please let me know how I can substitute values from available data for pedestal and perform manual check to see if anchors are passing. And then he has shared this image. It's a screenshot from Idea Statica. I didn't know that Idea Statica checks. I think this is the newer version which checks the anchors also as per this code. So I was not aware of this thing until Mr. Vasu informed me. So the newer versions of Idea Statica, it seems, it designs for the IS 1946 code, which I think is the code for anchor bolts in concrete. Let me just search it. IS 1946. Yeah, design of post-installed anchorage to concrete. Good, I didn't know that. So see, in this case, generally the failure occurs for your breakout in tension, as you can see. Most usually the failure will occur in the breakout. Okay, concrete breakout. So now if you refer to chapter 17 of ACI 318, I'll just open it. They have given, I mean, that is also a code, that is also a chapter which covers in detail about the anchors and different actions that you have to consider for anchor design. So when you do those calculations also, the most critical action is the breakout failure. I'm just opening it. Yeah, so concrete breakout and side face blowout. Not so much side face blowout, but concrete breakout is one of the concrete breakout under shear and concrete breakout under axial tension. Those are one of the important failure actions due to which your anchor bolts fail in tension. Now the American code tells you that you can avoid the breakout failures by providing reinforcement. So if you refer to and I'm not sure if Indian code tells you because I have not studied this code, but if you refer to clause number, I'm just writing it over here. Refer to 17.5.2.1 anchor reinforcement. This is in ACI 318-25 chapter 17. So if you refer to that, your code allows you to provide anchor reinforcements, and that is to avoid the breakout failures. So if you are providing those anchor reinforcements to avoid breakout failures, then you need not check for the breakout effects in your calculation. Are you able to understand what I'm saying? So your code gives you this option that if you are providing breakout anchor reinforcement, you need not check the concrete strength in breakout tension or breakout shear. So these two effects are usually the most crucial or critical effects due to which your pedestal shows failure or your anchors show failure. So that can be avoided by providing this reinforcement. So if you are providing this reinforcement, then in the settings option of Idea Statica, you will see a setting to switch off the breakout check. So in the setting, there will be an option. To switch off the check for breakout. So you just switch off that check for breakout and then provide the anchor reinforcement as per the 17.5.2.1 of ACI 318-25, and then you should be good enough to proceed with your pedestal size. So other checks you satisfy the tension check for anchor, you satisfy the shear check for anchor. For the breakout thing, you do what I just informed. that you provide anchor reinforcement. For that, refer to this clause, and in the settings option in Idea Statica, just switch off the setting which enables the, or let's say which disables the check for uh, which disables the check for breakout strength check. Okay, good. So I hope this answers your query. Then we move on to next question. Next question is from engineer Aditya Raj Mehra. He is from Delhi and he is a working professional. He is asking deck slab calculation with shear studs. No, so do you have any specific doubt? Because if there is no specific doubt, it's a long topic to discuss. So if you have any specific query or doubt related, please ask. Otherwise, if you just want to learn it from scratch, maybe refer some books. Refer some books which cover composite designs. Basically, the challenge in deck slab calculation will be to calculate the in-plane shear strength. That is the challenge that you will face. So if you have any specific query, just provide your question. You can also refer to some deck slab manufacturers' websites like Tata Comfloor, Tata Composite Floor, or I think there is this SMD manufacturers. So they have their own little software that they have uploaded on their website, design software. It's a free to download software, small software modules. So there they help you, or rather they help you to choose a design, a deck sheet profile, and then you can use the deck sheet profile and then carry out the design, and it will give you some design calculations also. So I'll suggest you to go to these websites, Tata Composite Floor, Tata Comfloor, or this SMD structural decks. I think they have they have their own design softwares which you can download free of cost. You download them, use those softwares. They also give you small design reports, so that will be helpful for you to understand the basic design process. Okay, then next question is from Mr. Rakesh. He is from New Delhi and he is an independent consultant. So he is asking, the SBC determined from a plate load test, should it be considered as gross or net? No, it is net basically, because you are digging a hole like this, and then at this level you are carrying out the plate load test. Okay, at this level you are carrying out the plate load test. So the SBC that you get over here, it can further take the overburden pressure, because you were checking in an empty pit, you are checking at this level. So this should be considered as net, because it can further take the overburden pressure. So once you add the overburden pressure, it will be called as gross. Until then, you call it as net. Good. So we have taken all the queries from the Google form. Now, let us take the queries from the live audience. So first question is from engineer Rohit Kashyap. He is asking, how do we calculate the rubber base isolator properties as per Indian codes to be used in ETABS? I don't know. I have absolutely no idea. Maybe you will need some shear deformation properties, but how to calculate that, I have no idea. Next question is from Mr. Magaj. Is Indian code sufficient for designing composite columns? I have not used the Indian code till now for composites. I think it is some 146 something. So I have never used it till now. So I don't know whether it is sufficient or if there are any limitations as such. But I guess it should be sufficient uh, because even the ETABS has now enabled the composite column design as per Indian standard 1 4 something something. So I guess it should be sufficient, although I have never used it. Okay then. So I guess these were the questions for this week. So that's all for this week then. You can continue to post your queries in the same Google form. You already know that the link throughout the week remains the same. You just need to put your queries in the same Google form, and once every week when we meet, you can connect with us online in these sessions. So this is the link for Google form. Yeah, this is the link. Click on this link to submit your queries. And if you want to connect with us on WhatsApp or messages directly on WhatsApp, you can just click on this link. I'm putting it in the live chat. Yeah, so to connect with us on WhatsApp, you can just click on this link and uh, message us directly. Yeah. So I think that's all for this session then. Thank you very much. Have a good week ahead. And now we will see you uh, next week with another episode of Ask AuxEn Anything. Till then, have a good time. Bye bye.